Okay, hello students. The goal of this video then is to describe all the equipment to you that is needed to perform gamma ray scintillation. And whenever you hear the word scintillation, that implies that you will be detecting gamma rays, but the scintillation part implies that you will be able to discriminate the energies of the gamma rays. So this isn't just a go, no-go in terms of presence of a gamma ray, but it'll actually tell you the energy of the gamma rays as we go. So here's sort of the equipment that we'll use. Of course, the primary importance is the detector, and you can see that right here. This is a sodium iodide thallium activated detector, and sodium iodide is, of course, a crystal, and that crystal needs to be sort of protected, so it's inside this aluminum case. And it's okay for it to be inside of aluminum case because gamma rays, as you know, pass readily through aluminum, particularly thin aluminum. This is probably about 2 millimeters thick or so, protecting the crystal so the gamma rays can pass right through the aluminum, typically through the front here for detection. The lower about fifth here of this assembly here is the high voltage area where the diodes are. And of course the diodes are what's critical for the electron amplification to make the very small photocurrent generated by the gamma ray penetrating the crystal into a measurable current that we can read using the equipment downstream. And you see a couple of cables coming out of the detector here that I'll talk about in just a second. So the next thing you see is this big aluminum box in front of you here, and you see these a lot of times in these nuclear counting experiments and things. And this is called a Nimcrate. And what the Nimcrate is sort of good for is that it's, of course, a sort of a housing for your experiment. And if you look in the very back here, you see a bunch of electrical connectors all the way in the back here. And these electrical connectors just provide a standard set of voltages for some NIM module that might be slid in. So the voltages might be plus or minus 12 volts, plus or minus 24 volts, plus or minus 6 volts, and of course ground. And the way it works is if you want to do some nuclear experiment, you sort of start considering what you need to do, and you go to some catalog for Ortec or something, and you can sort of buy these sort of handheld NIM modules. I have one in my hand here that's called an SCA. We'll use that in a later experiment. But so if you want to use it, you notice the SCA has an electrical connector on the back that matches these. So you just sort of put it up in the Nimcrate here, and give it a little push, and in it goes. And so it mates electronically in the back there to get its power. And of course you can just turn it on and start using it with the knobs that it has in the front. And of course they're all different. And typically these nuclear modules here have these coaxial connectors on the front. So the coaxial cable, as you can see, some of them we'll be using here, are definitely the glue that ties all these modules together. So we'll just pull this one back out here. We won't be using it, so I just reduced the experiment down to only the NIM modules that we'll be needing. And so let me talk about those now. And so the NIM modules that you do see slid into place here that we'll be using, I use sort of the right part of this Nimcrate here, and these are the NIM modules, of course, as I said. One is a high voltage power supply, as you can see here, and high voltage power supply is, of course, connected more or less directly to the detector through one of these cables over here, because as you read, high voltage is necessary to get that electron amplification process going in response to a gamma ray causing the scintillation detector to glow or scintillate. And of course the next NIM module I have is an amplifier right here, as you can see, and that'll be important for setting voltages to scale things so they sort of fit well with some of the data acquisition software that we're taking and so on. We'll see how that works in a minute. And of course the very last part over here isn't actually a NIM module. This little brown thing here is just sort of a on-off power supply. There's an on-off power button right there. Students do like to come in and spend some time wondering why things aren't working, but then because they forgot to turn it on. So that's an on-off switch that powers all of those electrical connectors that are in the back there. Okay, and of course if you wanted to check that the power supply is working, and there's little voltmeter taps here for the various voltages that this particular Nimcrate can supply. Okay, so that covers the detector, the Nimcrate, the NIM modules, and one of the last things we have here is a little brown box right here. This is called a Pre-Amplifier or a preamp. You sort of see it sort of written on the back here. So Pre-Amplifier or preamp. If any of you know anything about music or guitars, I think you know something about preamps as well. But what the preamp is for, at least in nuclear accounting, is that the raw signal that comes out of the detector. So I told you I'd talk about the cables. I guess I will now. So this thicker cable that you see right here, this first one right here, this connects directly to the high voltage power supply, sort of in the back of it. So that's how the high voltage is supplied to the diodes inside of this portion of the detector. So one cable is a high voltage. The other one is the signal that comes out of the detector. So this is a result of all the electron amplification, and the electrons eventually slam into the collection plate here and are eventually routed out through this cable here. So it turns out that the signal that comes out of the detector is extremely small. You can't really do anything with it. You have to be very careful with it. You're certainly not going to run it through an LED or any sort of electrical equipment because it's so small. And that's what the preamp is for here, this brown box. So this is sort of the input right here. This cable that you see on the preamp is coming directly from the detector. See this cable right here? Let me zoom out just a bit so you can see that. You can see that this cable right here is more or less coming directly from the detector. Not more or less, it is. So it goes into the input here. There's an input capacitor knob on here which serves as a filter. We have it set at 0 at the moment right now. And the preamplifier is especially designed to deal with these very, very, very small currents and boost them up sort of in a successful way. So boost them up without degrading the signal or changing its character and that kind of thing. It's just sort of the job that this thing does. You can see it itself has its own power, so it is plugged in. It has to get that ability to boost signals somewhere, and so the energy it boosts the signals with does come from the wall, power from the wall. And then, of course, there's an output on it, so the small signal directly from the detector goes in over here and comes out over here. So the preamp just sort of sits there and does its job. And at least what we're doing in this experiment here is we are running the output of the preamplifier, as you can see here, directly over here. And let me zoom in a little more right here. This is sort of a critical step. It's going directly into this thing labeled input. And if you recall, this is the amplifier. So the first thing we do when we get a signal from the preamp over here is we immediately send it to the amplifier to boost it even further. So sometimes students ask, well, can't I just take the signal directly coming from the detector, put it into this amplifier and just skip the preamp? The answer to the question is no. That's what the preamp's for. The signal coming right out of the detector is just too small to do anything with, but even amplified sort of using this coarse high gain amplifier that we see here, so it has to go in the preamp first. So it goes into the preamp, boosts it up to a usable level, then it goes into the amplifier. And the amplifier here, when you sort of look at it, just has some knobs on here, which are something you might expect. It has some gain knobs on it right here, like the top knob right here is sort of a fine turn potentiometer I can turn for very fine gain control. And then down here, the second knob is coarse gain, so I can boost the signal by a factor of 20 if I have it sitting here, factor of 50 if I have it sitting here, factor of 100 and so on if I have it sitting there. So these two knobs basically change the gain of the signal coming in from the preamp, almost like the volume control on a stereo. And then down here we have a bit of pulse shaping on here. There's a bit of rise time, again a filter for sort of cleaning the signal or getting rid of noise as needed. We can choose a bipolar or unipolar output. And then of course down here is where the output comes. All the way down here at the bottom. It's labeled output right here, and that's where the amplified signal comes out. And at this point, we're sending the amplified signal into two places. The first one on this cable right here is over to the good old trusty oscilloscope right here, because we're always interested in verifying the signals are working, so we just want to look at what's coming out of the amplifier. And the second place the amplified signal is sent, as you can tell right here, is into this little black box that sits in front of the amplifier. This is the data acquisition box. This is the one that takes the data. You can see on the other side is actually a USB cable, sort of a consumer level cable here. This takes that voltage and gets it routed properly into the computer for data acquisition. So that's basically it for the setup. So what's going to happen is the gamma ray is going to come in. It's going to cause the sodium iodide thallium activated crystal to scintillate. The high voltage is going to allow for amplification of the photocurrent. The photocurrent is going to be transferred out, or sort of allowed to pass out of the detector into the preamp. It will immediately get amplified into the amplifier. We will inspect the signal on the oscilloscope over here, and also route it into the data acquisition box for possible data acquisition on the laptop. And lastly, the high voltage power supply just sits here, biasing those diodes inside the detector. Sodium iodide crystal is what I was going to say, but inside the detector there. So the electron amplification can occur. So that's about it. That's about what you need for a basic gamma ray scintillation experiment. Okay. So in the next videos, I will introduce you to the radioactive sources we'll be using. Then I'll show you a quick tour of the core signal that is produced by the amplifier. And that's sort of the important last stage here, because again, the amplifier is connected directly to our data acquisition board. So we'll see exactly what data we'll be trying to take.